Hey everyone, and welcome back to the channel. Are you a B.Tech CSE student brainstorming ideas for your next mini project? Do you want to build something practical, visually appealing, and feature-rich that also strengthens your web development skills? Then you've come to the right place. In this comprehensive tutorial, we're going to build Recipe Finder Generator web application from scratch. This app will allow users to search for delicious recipes based on ingredients or dish names, or even get inspired with random recipe suggestions. Clicking on any recipe card will take them directly to the full recipe details. This project is a fantastic choice because it teaches you critical concepts like API integration, dynamic content generation, and building a responsive user interface. Let's quickly go over the key features you'll be implementing. A clean, modern, and user-friendly interface that adapts to any screen size. An intuitive search bar to find recipes by keywords like chicken curry or vegan pasta. A random recipes button for quick inspiration when you don't know what to cook. Dynamic display of recipe cards, showing an image and title for each recipe. Clickable recipe cards that open the full recipe instructions in a new tab. Robust error handling to inform users about network issues. API limits, or if no recipes are found. For this project, we'll be leveraging a powerful and practical tech stack, HTML, to structure the content of our web pages, CSS, Tailwind CSS, to apply beautiful, responsive styles with minimal boilerplate code. Tailwind's utility-first approach makes designing fast and efficient. JavaScript, the core programming language for all the dynamic behavior, user interactions, and API calls. Spoonacular API, a rich and free, with limits, food and recipe API that provides access to a vast database of recipes, ingredients, and food-related information. All right, let's dive into the canvas and look at our index, HTML file. As always, we have our meta tags for character set and viewport, which is crucial for responsiveness. You'll see the Tailwind CSS CDN linked here, which gives us access to all those powerful utility classes. We also import the inter font from Google Fonts for a clean, modern typography. Our entire application lives inside this main div. Notice the Tailwind classes. BG White, BG Opacity 95, P8 Rounded to, XL Shadow XL, Max W4, XL W Full Text Center My 8. These classes give us a nicely styled, slightly transparent white card, with padding, rounded corners, a shadow, and it's set to a maximum width to look good on larger screens, while still being W-full for responsiveness. Inside this section, we have our primary interaction elements. The input field, #search input with a placeholder. It's styled to be flexible and responsive across screen sizes. The search recipes button, #search BTN, and the random recipes button, #random BTN. Both buttons use Tailwind for attractive styling, hover effects, and focus states. These three divs are initially hidden. They serve as important feedback mechanisms for the user. Loading shows a spinner, error displays error messages, and no results informs the user if a search yields no recipes. This is where all the magic happens. This div acts as our container for dynamically generated recipe cards. The grid calls 1 SM, grid calls 2 MD. Grid calls 3 classes ensure that recipes are displayed in a single column on small screens, 2 columns on medium screens, and 3 columns on larger screens. Truly responsive design. Now, let's move on to the JavaScript, which brings our recipe finder to life. We start by getting references to all the important HTML elements using document getElement by id. This allows us to easily manipulate them later. You'll see const API_key equals sign, your API key. This is your Spoonacular API key. If you're using this code, make sure you have your own key from https://www.google.com/search, q equals sign spoonacular.com, as the provided one might have usage limits or expire. This is the base URL for all our Spoonacular API requests, a small but essential helper function before every new search or random recipe fetch. We call this to clear any old recipe cards, hide previous error no result messages, and display the loading spinner. This ensures a clean UI for each new query. This async function handles fetching recipes based on user input. It first calls clear previous state. It checks if the query is empty, If so, it shows an error. The API URL is constructed using the complex search endpoint, passing the query API_key and requesting number equals sign 9 results for a nice 3x3 grid. Inside the try-catch finally block, we await fetch API URL to make the network request, then await response JSON to parse the data. If response OK, checks for a successful HTTP response, 200/299 status code. If successful, and data results has recipes, display recipes is called. Otherwise, no results div is shown. The else block within try handles API-specific errors, like hitting daily limits or an invalid API key, by displaying the data message. The catch error block catches any network-related issues or unexpected errors during the fetch. The finally block always executes, ensuring the loading div is hidden. Very similar to search recipes, but it calls the /random endpoint of the Spoonacular API to get a specified count of random recipes. We default to 9. This function is responsible for dynamically creating and appending recipe cards to our recipe results div. It loops through the recipes array. For each recipe, it creates a div for the card, an img for the picture, and an h3 for the title. Tailwind classes are added to style each card beautifully with rounded corners, shadows, and hover effects. Important, we include img owner to handle cases where an image URL from the API might be broken. It falls back to a simple placeholder image. Each card is given a data recipe attribute, storing the recipe's unique ID. Finally, an event listener is added to each recipe card. When clicked, it calls open recipe details with the recipe id. This async function is triggered when a user clicks a recipe card. It makes another API call to the /recipes/ID/information endpoint to get more detailed information about that specific recipe, crucially including source URL, which is the link to the full recipe instructions. If successful, window open data source URL _blank opens that link in a new browser tab, taking the user directly to the full recipe. Error handling is also present here for any issues fetching the details. We attach a click event listener to search BTN to call search recipes. A click event listener on random BTN calls get random recipes. And for user convenience, a keypress listener on search input allows hitting enter to trigger the search. When the page first loads, we immediately call get random recipes 9 to populate the page with some initial recipes, providing a better user experience from the start. Once you have this code, save it as an HTML file. Let's say recipe app, HTML. Make sure you've replaced your _API_key with your actual Spoonacular API key. Then, simply open the file in your web browser. You'll see random recipes appear immediately. Try searching for pizza, chicken, or salad, and watch how quickly new recipe cards pop up. Click on any card, and a new tab opens with the full recipe details. It's that seamless. By completing this mini project, you've not only built a practical application, but also gained invaluable experience in responsive web design using modern CSS frameworks like Tailwind, dynamic DOM manipulation to create and manage complex UI elements programmatically, advanced asynchronous JavaScript with async await, and the fetch API for multiple API calls, integrating with a real-world API, Spoonacular, to fetch and display external data, implementing user feedback mechanisms like loading states and error messages. This project is a fantastic demonstration of your full-stack capability on the front end and your ability to work with external services. This project is a solid foundation, but there's always room for growth. Here are some ideas to take it further for your B.Tech mini project. Add filters based on dietary restrictions, vegan, gluten-free, or cuisine types. Implement a recipe detail page within your app instead of opening a new tab. Add a save to favorites feature using browser local storage or even a simple backend. Incorporate pagination for search results if the API returns many recipes. Improve UI UX with more animations or interactive elements. I hope this detailed walkthrough helps you ace your B.Tech mini project. This Recipe Finder app is not just a project. It's a stepping stone to more complex web applications. Remember, If you need full code, fill the form through link in description. If you found this video helpful, please give it a thumbs up, share it with your classmates, and subscribe to the channel for more valuable content. Let me know in the comments if you have any questions or ideas for future projects. Happy coding!
Please do like, share, and subscribe, and DM me if you need any help with your projects.